Hello children, welcome to AIMS India's online classes. In today's class, from mathematics subject, lines and angles topic we are going to continue. So in yesterday's class children, regarding vertically opposite angles we have learned. Based on that, some example problems we have solved. Let's continue the example problems children. So in figure, OE, in the figure, OE bisects AOC. The line OE, the ray OE bisects angle AOC. So this is AOC, and the OE ray bisects AOC, means this part will be equal to this part. So AOE equal to COE, and OF, this OF line, OF ray bisects COB, bisects this COB, means this part is equal to this part. So COF equal to BOF. So then show that we have to show AOB are collinear. AOB lies on the same straight line. They are collinear. That we have to prove. So OE, OF bisect angles AOC, COB respectively. So this AOC value will be 2 parts of EOC, because this part is x, this part is x, total part will become 2x. So total part equal to 2 times of x, 2 times of x. So AOC equal to 2 times of EOC. That is first conclusion. In the same way, COB, this big angle equal to double than this small angle. So COB equal to 2 times of COF, 2 times of COF. These two conclusions we can draw. So adding 1 and 2. So this AOC plus COB, big angle plus big angle equals to this 2 EOC plus 2 COF, 2 EOC plus 2 COF. We can convert this big angle into 2 times of small angle, big angle into 2 times of small angle. So these two big angles equal to 2 times common EOC plus COF. So EOC plus COF, which is equal to EOF. These two sum equal to this one, EOF angle, total angle. So instead of this, we can write this EOF. So AOC plus COB, AOC plus COB. So this AOC plus COB, they are lying on straight line. Their sum equals to 180 degrees, which can be written as 2 into 90 degrees. So this AOC plus COB can be written as 2 into 90 degrees. So 2 into 90 degrees, which means EOF equal to 90 degrees. So EOF equal to 90 degrees. EOF, this part equal to 90 degrees. This part, EOF will be equal to 90 degrees. So here children, here they have given OE equal to OF. OE is perpendicular to OF, they have given here. So that's why we are taking, in the place of EOF, we are taking 90 degrees, because in the question they have given OE is perpendicular to OF. So OE is perpendicular to OF. So that's why we are taking 90 degrees here, 2 into 90. So 180 degrees. So this AOC plus COB sum equal to 180 degrees. So if they are equal to 180 degrees, if they are linear pair, so this AOC and COB can be called adjacent angles. Adjacent angles. So AOC, COB are adjacent supplementary angles. So because they are forming a linear pair, and OA and OB are two opposite rays, so we can tell according to theorems, AOB are collinear. AOB are collinear. Like that we can prove. Next one. Next one. So, if ray OC stands on line AB such that angle AOC equal to angle COB, then show that AOC equal to 90 degrees. AOC equal to 90 degrees. So, ray OC standing on the line AB such that AOC equal to COB, then we have to show that AOC, this angle equal to 90 degrees, that we have to show. That we have to show. That we have to show. So since ray OC stands on line AB, on the line one ray is there, so the ray opposite this angle, opposite this angle, two sides of angle will forms a linear pair. So AOC plus COB equal to 180 degrees because of linear pair. But they have given AOC equal to COB. They have given both are equal. They have given these two angles are equal. So what we can do? So these are equal. So in the place of COB, we can keep AOC. AOC plus AOC equal to 180. 2 AOC 180. AOC 90 degrees. AOC 90 degrees. So, proved. Next one. Next one. In figure, lines L1 and L2 intersect at O. Here they have not mentioned O, children. Let this middle point be O. Middle point be O. Intersect at O, forming angles as shown in the figure. Means A, B, C, D. L1, L2 are two lines intersecting at point O, and they are forming four angles A, B, C, D. So if A is 35 degrees, A value 35 degrees, what about BCD? What about BCD? So lines L1 and L2 intersect at O, therefore, so A equal to C. Why? Because vertically opposite angles. So if A equal to 35, C also equal to 35 because vertically opposite angles. Vertically opposite angles. So next. Next, L1, L2 is the line. L2 is the line, or L1 is the line, and this is the ray. L1 is the line, and this is the ray. This is the ray here. So, ray opposite that side, ray opposite this side. These angles will form a linear pair whose sum equal to 180 degrees. So, A plus B equal to 180 degrees, but A value they have given 35 degrees. So, what we can write? 35 plus B, 180. B equal to 180 minus 35. B equal to 45. And one more thing. This B and D are vertically opposite. If B is 145, D also equal to 145. D also equal to 145. Like that, B value 145, D value 145, C value 35. Next one. Next question, children. So, in figure, determine the value of Y. Determine the value of Y. So, in the figure, they have given this figure. So, this AB line, CF line, DE line, they are intersecting at point O. Here 2y degrees, here 5y degrees, here 5y degrees. Some angles they have given here. Now determine the value of y. Y value we have to find. So here COD and EOF are vertically opposite angles. vertically opposite angles. So if this is 5y degrees, vertically opposite angle, this also will be equal to 5y degrees. So EOF equal to COD. So COD equal to 5y degrees because EOF equal to 5y degrees. That is one conclusion. This is 5y degrees and this AB line, this is AB line and OA and OB are opposite rays. So the angles which are lying on the same side, they will be equal to 180 degrees. Means 5y plus 5y plus 2y. So means AOD, DOC, COB 180 degrees. So 2y, 5y, 5y 180 degrees. Total 12y 180 degrees. Y equal to 180 by 12, 15 degrees. So y value 15 degrees. Next one. In figure, AB and CD are straight lines and OP and OQ are respectively the bisectors of angles BOD, AOC. Show that rays OP and OQ are in the same line. So here children in the figure, so AB is a line, CD is a line and OP, OQ are the bisectors. Means OP line bisects this BOD into two parts. This OP line bisects this total BOD into two parts. Part 1, part 6. This OQ line bisects this total part into two equal parts. Part 3, part 4. Let the points above O is 2, below O is 5. Altogether we have 6 angles here. Altogether we have 6 angles. We have to show OP and OQ are in the same line. So in order to prove OP and OQ are in the same line, it is sufficient to prove that this POQ equal to 180 degrees. This POQ means the angle formed at O. The angle formed at O, POQ, this angle equal to 180 degrees, that we have to prove. If it is proved, they will be on a line. So for that children, for that OP is the bisector of BOD, angle BOD. So angle 1 equal to angle 6. OQ is the bisector of AOC. So angle 3 equal to angle 4. Angle 2, angle 5 are vertically opposite angles. So angle 2 equal to angle 5. Sum of all the angles at point O. Sum of all the angles at point O is 360 degrees. So 1 plus 2 plus 3 plus 4 plus 5 plus 6. Total sum of all angles 360. Total all angles 360. So in this 1 plus 6 we can write together. 3 plus 4 we can write together. 2 plus 5 we can write together. But 1 and 6 are equal. In the place of 6 we can write 1. 1 plus 1, 2, 1. 3 plus 3, 2, 3. 2 plus 2, 2, 2. 2 we can take common. 2 of angle 1 plus angle 3 plus angle 2 equal to 360. So angle 1 plus angle 2 plus angle 3 equal to 2, this will come this side. 360 by 2, 180 degrees. So angle POQ. What is angle What is angle 1 to 3? 1, 2, 3. This total angle means it is the angle formed at O. This side we have P, this side we have Q. So it is angle POQ. Angle POQ 180 degrees. So OP and OQ are lying in the same line, same straight line. So that indirectly we can prove. Next one. So in figure, two straight lines PQ and RS intersect each other at O. Intersect each other at O. If POT equal to 75 degrees, find the values of ABC. Find the values of ABC. So here children, PQRS. PQ is one straight line, RS is one straight line, which intersect at O. Which intersect at O. If one more T they have given here, OT. If this OT, POT is 75 degrees, so what about ABC? If this angle is B, this angle is A, this is 2C, this is 4B. What are the values of ABC that we have to find? ABC we have to find. So OR, OS are in the same line. OR, OS are in the same line. So total angles this side will be equal to 180 degrees. Or this side will be equal to 180 degrees. Either that side or this side. So if you take this side, so ROP, POT, TOS, first angle, second angle, third angle. So ROP, POT, TOS, sum of all these three angles 180 degrees. This is 4B, this is 75, this is B 180 degrees, 4B plus B, 5B plus 75 180 degrees, 5B equal to 180 minus 75 105, B equals to 105 by 5 21 degrees. So 21 degrees. And this PQRS intersect at O. Intersect at O. So QOS. So this part for the point this side angle equal to for the point this side angles. So A equal to 4B. A equal to 4B. A equal to 4B. A 4 into B value how much? 21. 4 into 21, 84. Next. So from this point, this vertically opposite angles. For the point, vertically opposite angles means these two. Or let's do another method. So we have to find, already we have got B value, we have got A value. Now we have to find C value. C value. This RS is one line and this OQ is a line standing on that. So this side 2C, this side A. This will be linear pair 180 degrees. So ROQ, QOS 180, 2C plus A 180, 2C plus 84 180, 2C equal to, this will come this side, 180 minus 84 96, C equal to 96 by 2 48. So A value, B value, C value. Next one. So in figure, if angle AOC plus angle BOD equal to 70 degrees, what is angle COD? What is angle COD? So if AOC plus BOD equal to 70 degrees, what is angle COD? So AOC, let it be X, BOD, let it be Y, equal to 70 degrees. So then what is this COD? So but this is AB is the line. So all the angles lying on the same side of the line equal to 180. So AOC plus COD plus BOD 180 degrees. But AOC, BOD, let's keep them separate. COD, let's keep it separate because we want to find COD. AOC plus BOD, already they have given 70 degrees plus COD 180. COD 70 will come this side minus 170, which is equal to 110. So COD equal to 110 degrees. Next one. In the figure, find the value of y. So this is the line. Same side of the line. All angles will be equal to 180. So 2y plus 3y plus 5y equal to 180. So 10y equal to 180. So y equal to 180 by 10. That equal to 80 degrees. So we have solved problems children based on vertically opposite angles and complementary angles, supplementary angles, adjacent angles and linear pair. Based on that concepts, we have solved all these problems. Now children, next concept we have is parallel lines. The concept is regarding parallel lines. So the lines which are in the same plane, and do not intersect each other, though they are extended this side, but if they do not intersect at any side, and distance between parallel lines is same anywhere. The distance between the lines, if you check anywhere, if the distance is same, if the distance between the lines is same everywhere, and if they won't intersect at any place, so then they are said to be parallel lines. Means the lines which never intersect are called parallel lines. Next one. So we have a concept called transversal line. So a line which intersects two or more given lines at distinct points is called a transversal. If we have two lines, if we draw a line like this, it is intersecting two lines at two different points, point A, point B. So this is called as transversal. Suppose if we have lines, if we have two lines, we have a line like this. It is intersecting only one line at one point. So this is not the transversal. So two lines or more lines, if it cut them at more points, so then it is called as a transversal. So here L and M are the lines, P is the transversal, and AB are the different points at which this transversal intersected the given two lines. So for two parallel lines, there will be a transversal line. So the part of transversal, this total line P is called transversal, but here AB is a part of transversal which lies between the parallel lines, and this part is called intercept. This part is called AB intercept. Means it's a part of transversal. Next, let's see the important points regarding this parallel lines and transversal. So two angles on the same side of transversal are known as corresponding angles. If both lie either above the two lines or below the two lines. Above the two lines, below the two lines. The two angles on the same side of the transversal are known as corresponding. If both lie either above the two lines or below the two lines. Means, so we have two lines. This is one transversal line above, same side. This A and B. Here, see this. This 1 and 2 are called corresponding angles, or 3 and 4 are called corresponding angles, They should lie on the same side. So these are examples of corresponding sides. Next, the pairs of interior angles on the same side of the transversal are called pairs of consecutive interior angles. Pairs of consecutive interior angles. Consecutive interior angles. So here not given. So for the two lines, if this is the transversal, the pairs of interior angles, they should lie within the lines like this, same side of transversal, left side only, they should lie in the interior part. So these two angles, this pair is called consecutive interior angles. Consecutive interior angles. Like this, if we have two lines, if this is the transversal, these two are also considered as consecutive interior angles because they are lying on the same side, lying in the interior part of the transversal parallel lines. So they are consecutive interior angles. Next, if a transversal intersect two parallel lines, if the lines are parallel, if the lines are parallel, if a transversal is drawn for the parallel lines, so then this corresponding angles will be equal, x equal to y, or this side, so a equal to b, or line downside, angle p equal to angle q, like that. Corresponding angles are equal. If a transversal intersect two parallel lines, if a transversal intersect two parallel lines, so then these two angles are called alternate interior angles. So if this is x, if this is y, if this is z, x and y are called consecutive interior angles lying on the same side. X and z are called alternate interior angles. Alternate interior angles means for the transversal, one is that side, one is this side. So they are called alternate interior angles. So they are also equal. So x equal to z. Angle x equal to angle z. But these consecutive interior angles are not equal. Here x plus y equal to 180 degrees. So they are supplementary. If two parallel lines are there, if we draw a transversal, so these two are called interior because they are lying within the parallel lines. They are called interior angles. They are lying on same side, so they are called consecutive interior angles. This is x, this is y. This x is not equal to y always, but x plus y equal to 180 degrees always. They are supplementary. But whereas if this is x, for the transversal this side, downside, if this is upside, this one downside angle, if it is z, this xz are called alternate interior angles. That alternate interior angles are always equal. Angle x equal to angle z. Next one. if a transversal intersects two lines such a way that pair of consecutive interior angles are supplementary, then the two lines are parallel. Suppose we have two lines, we don't know whether they are parallel or not. This is the transversal. These are the interior angles x and y. If you want to check whether they are parallel or not, how can we check? If x plus y equal to 180, or if consecutive interior angles are supplementary, then the two lines are said to be parallel. Two lines are said to be parallel. Next, if two parallel lines are intersected by a transversal, if two parallel lines are intersected by a transversal, the bisectors of any pair of alternate interior angles, this is one pair of alternate interior angles, this is second pair of alternate interior angles. We have two pairs here. The bisector of any pair, the bisector of any pair means this angle, suppose L, M are the parallel lines, P is the transversal, this is so this line, let it be A, this line, let it be B. What are these AB lines? They are bisecting a pair of alternate interior angles. Means these two are alternate angles. This line is bisecting this angle. This line is bisecting this angle. So then these two lines also will be parallel. AB lines also will be parallel. AB lines also will be parallel. Next one. If two parallel lines are intersected by a transversal, if two parallel lines are intersected by a transversal, bisectors of any two corresponding angles are, these two angles are parallel, these two angles are corresponding, they asked about corresponding. This is transversal. Corresponding angles means they should lie on the same side. For this line above, for this line above, they should lie on the same side of the line. Same side of the transversal, same side of the line. So they are called corresponding angles. So then the bisector of this, the bisector of this, these two also will be parallel. These two also will be parallel. Next one. So if the bisectors of pairs of corresponding angles by a transversal are parallel, then the lines also parallel. Reverse to this. If lines are parallel, bisectors of corresponding angles are parallel. If bisectors of corresponding angles are parallel, so then lines will be parallel. Next, if a line is perpendicular to one of the two given parallel lines, suppose two parallel lines are there, this is the transversal. If this transversal is perpendicular to one line, automatically it will be perpendicular to second line because these two are parallel. Next, if the side of a triangle is produced, if this is the side, triangle, if the side of triangle, if the side of this triangle is produced, then this extended line and this side, the angle formed between the extended line and its adjacent side will be considered as exterior angle. It will be equal to opposite sum of opposite interior angles. This will be adjacent. This will not count. This is opposite angle to this exterior angle. This is opposite angle to this exterior angle. Suppose this is x and y. This exterior angle equals to x plus y. So, one exterior angle equal to sum of the opposite interior angles. Next, if you have a polygon, polygon means having many sides. If all sides are equal, if all sides of polygon are equal, then it is called as a regular polygon. So next here, sum of all the interior angles of a polygon of n sides. So 1, 2, 3, 4, 5. Here we are having 5 sides. Now the question is, what is the sum of all the angles? We know for a triangle it is 180 degrees. For a rectangle it is 360 degrees. Like that, if we have 5 sides, 6 sides, like that, if we have more than 3 sides, more than or equal to 3 sides, then it is called as a polygon. For polygon, sum of all the interior angles, the formula is n minus 2 into 180. Triangle, 3 sides, n minus 2 into 180. N minus 2, how much? 1. 1 into 180. 1 into 180 equal to 180. Next, quadrilateral, 4 sides. N minus 2 into 180. So, 4 minus 2 into 180. 4 minus 2, how much? 2. 2 into 180, 360 degrees. Next, pentagon, having 5 sides. N minus 2. 5 minus 2 into 180. 5 minus 2, 3. 3 into 180, 540. Pentagon. Like that, any question. If they ask what is the sum of polygon which is having 10 sides, so then 10 minus 2 into 180. 10 minus 2, 8. 8 0 times 0, 8 8 times 64, 8 1 is 4. 8 plus 6, 40. 14. 1440. Like that, we can find sum of interior angles of any polygon which is having sides more than or equal to 3 with the help of this formula. So each angle, then each angle will be equal to, suppose 180. Suppose triangle, sum 180. Each interior angle of, they are asking about regular polygon. Regular polygon means all sides are equal. Triangular, if the all sides of equal for a triangle, then it is called as a regular polygon. Now, what is the measurement of each interior angle of a regular polygon? So, n minus 2 into 180 by n. So, 3 minus 2 into 180 by 3. So, 180 by 3, that equal to 60 degrees. Equilateral triangle. Next one. Sum of all the exterior angles formed by producing the sides of polygon. If we have a polygon, we can extend all the sides. If we extend this side, one exterior angle. If we extend this side, one exterior angle. If we extend this side, one exterior angle. We have got 3 exterior angles. The sum of 3 exterior angles will be equal to 360 degrees. So any polygon, exterior angle sum always equal to 360. Interior angle sum may be different. For triangle 180, for rectangle 360, for pentagon 540. Interior angle sum may be different, but exterior angle sum always equal to 360 degrees. Suppose if you know the angles, suppose if the angles are if the sum of interior angles of a polygon is 720 degrees, then what is the value of, if the sum of interior angles of a polygon is 720 degrees, then how many sides will it have? If it be, let it be n. Let it be n. So, for that n formula, number of sides of polygon. Number of sides of polygon. If you know one angle, sorry children, if you know one angle, so then the formula is 360 degrees minus, so 360 degrees divided by 180 degrees minus each interior angle. Each interior angle. So this we will learn later, children. This concept will come. So these are the corresponding angles, children. These are the exterior alternate angles. That side, this side. That side, this side, outside. Exterior alternate angles. These are interior alternate angles. These are co-interior angles or consecutive interior angles. Consecutive interior angles. Like that, we have so many angles, children. Okay, children. Thank you for watching our video. So please subscribe our channel and press the bell icon for receiving latest updates, children. Thank you. Have a good day.